current running job?
Some of the challenges that we'll have to deal with is the limited amount of time we have to set up the actual Boeing server. To get it running correctly and with all the options that we want, it will take a decent amount of time, as well as all the testing and preliminary to make sure that it works. With compatibility, we will be converting MATLAB code into C code. So this will be turning it into more of a platform-specific compilation. So that's one of the issues we're going to have to look at to make sure it's working correctly. With our design simulation, we need to create code that will be able to model after the wireless that we are hoping to achieve, as well as other testing that we can actually make sure that it's working correctly. And with the scalability for our testing at first, we're not going to have very many volunteers, so it's not going to be a large grid of computers, but and being able to test it to see as the amount increases that we're going to actually be able to manage that, and then benchmark so we can make sure that it's actually properly sending the code out in parallel and actually reducing time on running. And for that, I believe we're using a Monte Carlo problem to actually test.
All right, so in conclusion, as we said before, we are looking at trying to set up the volunteer computing grid at WVU. Our goals, one last time, is to have an inexpensive pool computing power that's available to everybody. This should help for research that might have not been possible before because of the computing power required on it to run different simulations. We're hoping to be able to run large-scale, like we're saying, wireless web interfaces, wireless 3G, 4G modeling, things like that that would normally take a week on a single machine to do and consume less time. That's really. Does anybody have any questions regarding the volunteer computing?
So, what kind of incentives are you going to have for people to, donate their computing time?
What we're going to try to do is set up like a credit-based system where we encourage researchers to donate their extra computer cycles by giving them credits that they can then use, turn around and use to run jobs themselves. So basically, if a researcher wants to put a job on the grid, it's going to look at the number of credits it requires and basically debit their account that many.
So if you're giving credits for the amount of computing time that's donated, how do you account for the variability in systems? So one guy can have a real old computer, that actually isn't doing that much processing, and then you got someone else who's got a new computer who's, for the same amount of times, doing a lot more processing.
Pretty sure Boeing has a way of handling that. It tells how much. I don't know what the exact numbers are of how it handles it, but it puts numbers to it somehow so that, because I mean it's chopped into such little pieces. The slower computers only can complete maybe 3 pieces at the same time that another machine completes 10. Because they're just broken up into such small parts.
You said one of the things you will not be able to do is check out the scalability because you don't have many volunteers. Is that correct?
I think just initially we're going to only have a few volunteers, and we want to scale up from there.
But do you have some part of your system where you need to actually focus on the scalability aspect, even if you are not able to?
Other than the server being able to handle a large load of input and output files, not particularly.
What my question is, have you identified any kind of failure modes associated with scaling up? That is, when a large number of people volunteer, have you identified any vulnerabilities in your system that it could in fact fail?
I mean, the Boeing software itself is already ran in several different institutions, basically already running a similar setup. And it has a SETI at home, for instance, is one of the people who use it, and it's got hundreds of thousands of people that run it. And it's really the main thing that's going to be interfacing with all the different volunteer computers and research computers. So we don't really anticipate there being a problem with scaling it up. But we also want to make sure that it'll work with 5 or 6 computers that we're going to start out with and be able to show that it works. So.
Back to Dr. Valenti's incentive questions. I understand incentives for researchers to donate, but what about getting student body to donate? What incentives can you give them to get them to donate their use cycles when they won't have any use to turn it around? Just something I thought of.
There could be similar incentives to like Folding at Home, which is one of the largest distributed computing systems, where people donate purely for the fact that they're getting these credits that they can, you know, show that our team, because you can group together more than one user. They say our team has, you know, completed 100,000 work units, and they get like a certificate. That completes
So
the
just certificate, just
yeah.
feeling good
Feeling
about
good that you're
yourself.
donating
The
to a
feel-good
cause.
factor. Okay.
We're also gonna have the statistics.
Yeah.
We're gonna have statistics that are available as far as like top donators, things like that. So they can also be viewed in competitions and, you know, with student organizations. Be like, hey, we're gonna have this competition, and between these different student organizations within engineering and teams engineering plus that type of stuff. So
Yeah, that's a good idea.
I think you will be mobbed with volunteers if you offer pizza for every 1,000.
How about beer? That's a good motivator for students, right?
Okay.
Are there any other alternatives to BOINC that might be a little easier to work with, still accomplish the objective?
There's a system called Frontier, the network that the university actually runs in some of their labs currently. But the disadvantage to that is you have to pay a license fee per use. So you can't really scale up to, you know, 1,000 computers without paying $60,000.
Or how about cobbling something together yourself? Or that be too
Well,
complicated?
the BOINC is open source, so we can change it.
You kind of use the pieces of BOINC you need, or something like that.
we don't see a need to reinvent the wheel, so to
Yeah.
speak. If it's already there, why spend the hours and hours that it's gonna take in recreating this software?
And we didn't just want to use it, we kind of wanted to improve it and build it more into like an integrated system, have the monitoring and the web interface for the researchers. So I think inevitably we'll be like improving and working on one instead of just, you know, implementing it.
Most BOINC projects are only like to one goal. We want ours to be able to run, you know, various simulations for all sorts of different goals, basically. Not just study at home, just looking for, you know, certain signals.
We also plan to package it for Debian, so anyone with a server could install it, set it the way they want it, and set up their own grid in maybe a few hours. Hopefully, that's our goal. Anyway.
Okay, thank you very much. Okay, I think now group one can go now.